When we talked about Moore's Law, I mentioned, yes, there's a hyperthreading note set. Well, this is it. So when we talked about Moore's Law, we talked about one way to take advantage of increased capacity on a chip. If you don't have enough room for more cores, you can put more states. Well, okay. So if you do have room for more cores, then this is the kind of transition you make from one state, one core, cache we're going to ignore right now, to two states, two cores. And then from that, we would go to four states, four cores. But there are intermediate steps. So again, if you don't have enough chip capacity yet to put two cores on, what you do is put one core on, but two states. And the states are registers, program counter, and stack pointer. Then when you get more chip capacity, you now double the cores. So here we're doubling the states, here we're doubling the cores. Here we're doubling the states, here we're doubling the cores. And anytime you have more states than cores, that's called hyperthreading. And what hyperthreading lets you do is if you've got, say, two threads assigned to that core, is when one thread blocks, the other thread can take over instantly because its state is right there already on the chip. So, this is a good deal. So I once sat down trying to come up with some sort of theory about, you know, how good is hyperthreading? What does it really get you? And so let's let H be the fraction of a CPU's capacity or a core's capacity that one hyperthread can keep busy, which means if it's all compute and doesn't have to fetch from memory, that's a pretty high number. Like that could be approaching 100%. But if it's fetching from memory a lot, it's going to block a lot, and H is going to be a small number, zero point 0.1, zero point 0.2, something like that. Okay, but if H is just the fraction of a core's capacity that one hyperthread can keep busy or one thread can keep busy, then that means there's 1 minus H that's not being used. So now let's say we add another hyperthread running the same program. Well, if that hyperthread is capable of keeping H% of the core busy, then that means of that 1 minus H that the first one has left over, 1 minus H% of that is now left over from both of them, and so on. And so if you have n hyperthreads, the remaining unused capacity would be 1 minus h to the nth, or the capacity in use would be 1 minus that. Okay, and if this is the capacity in use, and this is what you would hope to get, or what you could get with just one, then this is the expression for the speed up. And here's what you get if you graph that. So now let's take a look. So the horizontal axis is h, the fraction that one can the hyperthread running this particular program can keep a core busy. If that's big like zero point 0.9, well, then there's just not a huge advantage in hyperthreading because there's no reason for a thread to stop and another thread to take over. And so here we've got well, 2, 3, 4 hyperthreads are sort of in the same spot, but you can see it doesn't do much of a speed up. However, where you get good speed up is down here when, let's say that one thread running this particular program can only keep the core busy 20% of the time. Well, now if you add a hyperthread, one, you can get a lot more work out of that same chip. And if you add another, and if you add another, you can get a lot of work out of the chip. And so this gives you sort of a sense, when you go to buy a CPU and it says, oh, we've got 8 cores with hyperthreading, or 4 cores with hyperthreading. Let's use that example. If it says we've got 4 cores with hyperthreading, well, that means you've got 8 threads for 4 cores. And you think, well, does that get me anything? It does if the program is such that it operates down here. It doesn't if the program is such that it operates up here. And so this kind of realization is what you would need to figure out whether the hyperthreading actually gets you something or not. And that's why this chapter is subtitled Almost Amdahl, because this is almost like Amdahl's law. Amdahl's law will help you figure out if getting more cores will do you any good. And then this hyperthreading theoretical equation will help you figure out if hyperthreading does you any good too. And then this is the graph repeated from the Moore's Law notes. Again, I got it from somebody else, so it reverses our axis standard. So fast is down, but it was a 4-core machine with hyperthreads. And so here is the, going down being fast. 1 thread to 2 threads gets you a lot. 2 threads to 4 gets you a lot. 4 to 8 in this case only gets you a little. Okay, but it's significant. And so in this case, it's if you happen to have 4 cores with hyperthreads, turning on 8 threads really did make a reasonably significant difference.